In this video, we are going to talk about solving linear systems of equations by graphing. So when we are talking about solving a system of linear equations, what we are looking for is the point that makes both equations true. When we're talking about graphing, what we're looking for is where the lines intersect. So no matter what method we are using to solve a system of equations, we're always looking for the point that makes both equations true. When we're graphing, that's where the lines happen to intersect. So our steps are pretty simple. We're going to graph each line. Remember, you want to consider whether you're using your slope-intercept or your standard form. And think about which key features you're going to use in order to do those. And you look for where they intersect. Remember, this will be a point, x comma y. And then you can check your answer by plugging into both equations. They should both be true. Let's take a look at a couple of examples. So in example 1, we have this system, y equals x minus 4 and y equals negative 1/2 x plus 5. These are both in slope-intercept form, so I can go straight to graphing. For my first one, my slope is 1 and my y-intercept is negative 4. So I'm going to go down, my y-intercept is negative 4. So I'm going to go down to negative 4, put a point on my y-axis, count my slope of 1. So up 1 to the right 1. And because I need this to be pretty exact, I'm going to go ahead and count it out several times in both directions. And then I'm going to connect and extend through. So that's my first equation. My second one, my slope is negative 1/2, and my y-intercept is 5. So I'm going to go on my y-axis, 1, 2, 3, 5. Then a slope of negative 1/2, so down 1 to the right 2. Or up 1 and to the left 2. So these are intersecting at 1, 2, 3, 4, 5, 6, comma 2. That point right there is 6, comma 2. Now I can check by plugging in. X equals 6, y equals 2. This is me checking. So y equals x minus 4. It would be 2 equals 6 minus 4, which is true. And then y equals negative 1/2 x plus 5. I'm plugging 2 in for y, 6 in for x. Remember, 1/2 times 6 just means 6 divided by 2. So that's 3, negative 3. 2 equals negative 3 plus 5. Again, that's true. So I can be confident that I did it correctly because that point makes both of the equations true. So ultimately, my answer is that. That's my answer. The rest of it is my work and my checking. Taking a look at example 2. In example 2, these are both in standard form. So I'm going to need to find my x and my y intercept for each of them. So for the first one, negative x plus 2y equals 4. To find my x-intercept, I'm going to let y equal 0. That'll just be 0. Dividing by negative 1, I get x equals negative 4. So my x-intercept is negative 4. Finding my y-intercept, I'm going to let x equal 0. Dividing by 2, I get y equals 2. Remember, this is two separate points. This is x is -4, y is 0. This is x is 0, y is 2. So plotting my 2 points, my x-intercept at -4, my y-intercept at 2, I'm going to connect, and I'm going to extend through. If you have a ruler, it's pretty important that these are precise. My other equation, 2x plus y equals -3. I'm actually going to solve this one for y to get it into slope-intercept form, just because it's easy. It's less work. Now I can plot my y-intercept of -3. Remember, my slope is -2. Put it over 1, so it's a fraction. Down 2 to the right 1. Or up 2 to the left 1. Again, using a ruler to connect and extend through. And then looking for the point where they intersect. Right there. So -2, 1. That's my answer. I should plug in to check. We're going to leave that to be done in class. That is all there is to solving by graphing.